All right, so the last two problems, this ones are going to be probably the most crazy ones out there. Now, mainly because conceptually they're the hardest ones. Okay, well, the triangle one's not too much, but at least this one is. So let me read it. For each real number r, which of the following points lies on the graph of each equation in the x, y plane for the given system? So, first thing, just remember this is a system of equations, okay? So that means, and this is what I'm saying, whatever you plug in, if it's your x, you need to get a certain value for y. So right here, they're giving us x and y. So even though they look weird, this is x and this is y for all of them, actually. So this is x and this is y. That is the concept that we're going to be using today. Now, I didn't catch this when I was first working on it. But if you notice, the first equation, the second equations are very similar without even knowing it. If you divide this one by 5, I believe, yes, by 5, you're going to get 2x plus 3y equals 7. Now, the reason why this is important is because the only difference between the first equation and second equation is that second equation is getting multiplied by 5. All right? That means that this is going to make both of the equations what they call is coincident, which means if one point lies on one of the graph, the same point is also going to be true for the second graph, the second equation. So in other words, what this is beneficial for us, all that math sense nonsense, is that if we plug in a point for that one and it works, it's also going to work for the second one. So we don't have to double check for the other to see if both the equations are going to go ahead and work. So we can only check on one of them. So now the hard part is you're going to have to go ahead and plug in x for all of those and see what you get for y. Okay, so for example, I'm gonna skip number one, because I did that one and that one's gonna be kind of crazy. Pick the easiest ones. Number one is really hard and it was probably like just make you just not want to do this problem. So I'm gonna skip number one just for right now. Now we might end up going to that one later, but for right now we're gonna skip this one. So I'm not gonna do this one just right yet. I'm gonna focus on the other one because they look a little simpler to me to plug in and see what I get. Now, what you're going to have to do is you're going to have to get your x, which let me erase a lot of stuff here. Yes, a lot of stuff that might get confusing. I'm going to grab x and I'm going to plug it in into the equation, this equation, and see what I get for the y value. Okay. Now, oh, I forgot. All of this is getting plugged in. All right. And we're supposed to get y is supposed to be that. Okay, that's what we're supposed to be getting for the y. So let's go see if this works. So we're going to go ahead and start writing our problem. So I'm going to go ahead and put 2 parentheses negative 3r over 2 plus 7 over 2. Now this is going to be plus 3y equals 7. Okay. So let's see if that's true. Okay, so what we're going to do, we're going to go ahead and multiply this over here. Now, the benefit of this one's actually pretty easy. Now, this cancels with those two. And we end up with 3r plus 7 plus 3y. Okay? Pretty easy. Now, we also have 7 over here. So now we're going to have to move and solve for y. So we subtract this one. Minus 7. Minus 7. So those two cancel out. So that becomes 0. So right now we have 0 on the side. And now over here we have 3y. And also we have negative 3. So that's positive. And this one's going to be negative over here. Okay. Now what do we have to move? This one, so we're going to do positive 3r, so that cancels out. Positive 3r, that cancels, or that just going to add up. And now we have this. At this point, we're going to go ahead and divide both sides by 3. And guess what? Y is equal to r. And if you can see, Let me erase that. If you can actually see your problem over here. What did we say r was going to have to equal to? R. So we can tell that my answer is going to be actually B. So we don't have to go ahead and plug anything else. But if I was doing this, like I said, plug in the easiest ones that you may see. Because the other one, I did plug it in and it's just a whole mess. You have to go ahead and multiply a lot of fractions and stuff like that. So just work on the numbers that look a little bit easier and then see if it works. Right? Now, technically, we could have plugged those in first because it's just R. Should be pretty easy to go ahead and do it. But I was just basically going to go in order. So for the first one, I was going to do that one last just in case. Because if that's my answer, then I know I don't have to plug it in. And I get rid of all that mess. So yeah, so that's the answer for that one. Hopefully that kind of makes sense. It's just system of equations. Both of the equations, basically, you just have to use one of them. If that point works for one of them, it also works for the other one. So you don't really have to plug it in for the other. And that is it for that one. Now let's go ahead and go over the next one. It's saying the perimeter of a equilateral triangle is going to be 624 centimeters. Okay, so the height of this triangle is going to be k square root of 3 centimeters. Okay, now where k is a constant, it's just going to be a random number. What is the value of k? So first of all, this is the type of triangle that we have. I'm going to go ahead and show you. That is the triangle that we have. But what they're giving us this information over here. They're telling us what k and that stuff is going to be. So basically, we're going to have to divide the triangle, the first one, in half. And now they're going to tell us, once we divide it in half, is that this side is going to be k square root of 3. Now, due to the fact that this is a special triangle, and this is just information that you're just going to have to know, is that the sides are going to be on the bottom, just k, and on the other one, the hypotenuse is going to be 2k. What they're asking us to do at this point is figure out what is going to be my k value, this guy right here, or this guy right here, or this guy right here. Okay, we can just whichever we want once we know the formula, or once we know how it separates into the special right. But first, perimeter means that every side, this, and this is going to have to add. And we know this side, and this side are equal to each other. So what I would highly recommend to do in this problem is we're going to get 624 and divide it by 3 to figure out how long every side is going to be. Oh, that's supposed to be a 4. So we're going to go ahead and divide this. So we'll divide it by 3. The first one's going to be 2, right? Now, can I divide? Okay, so that's 6, so minus. So that's 0, and then this comes down. Can we divide those two? No, so that's a 0. We bring this one down. That's 24, and that's 8. Okay, so that's long division, basically. And that's, yeah, that'll be 24, and that's 0. 0 remainder. So now we know every side is going to be 208. 208. 208. Now, if we look over here on this triangle, we know that the hypotenuse is this length right here. And this is how I did it. It's going to equal to 180, the whole hypotenuse. But k is going to be a constant, so it's just going to be a random number. So what is k? So we solve for k now. So 2k is equal to 208. We have to divide both sides by 2. So k is equal to 104. And that is your answer for this one. The k value is going to be 104. But the hard thing about this problem is that you need to understand what a special right triangle is, and especially the 30, 60, 90 triangle. Other than that, that's basically it. This is going to be all of the ones that I'm probably going to go over in class or on these videos. And then the rest, we're going to have to remember a couple rules for the SAT. And also, we're going to have to do some calculator skills in class, I believe. Because at least I can help you out with those. Like, on that point, we can try and get over the calculator part pretty quick. But this stuff is just stuff that you're just going to have to use every tool that you have, basically, in math. So just remember everything that you've done so far in math and try and apply it. Alright, so that's all I can say. So that was the last video. And that was only 2 problems, and it took me 9 minutes just to do those 2. Well, obviously I'm kind of explaining them a little bit, so I probably could have finished them a little faster, but still, like, they do take quite a bit. So just bear with me. I'm going to put this PDF on there just so you guys can see exactly what I did and how I did it. And yeah, it's every single problem that we went over. And there we go. All right, see you guys. Have a great day.